Hi everyone, welcome back to Math 112. This is Scott. Let's get started. What we will be talking about today is section 5.4, in which we will be exploring the graphs of the sine and cosine functions. Alright, so the basic idea here is that sine and cosine just happen to be two functions, and functions can be graphed. And the setup is just going to be this. So setup. We're going to use the letters X and Y just in their capacity as generic signifiers for input and output, and in other words, horizontal and vertical coordinates of the graph. So setup will use y equals f of x as the generic format with x for input and y for output. So the x and the y here that we are using are now uncoupled from the x and the y that we were specifically referring to for points on unit circles or other circles. So now, in other words, so free the x and y, free those symbols from their roles as coordinates on circles. So it's unfortunate, but we have a relatively limited stock of notations available to us when it comes to graphing things, and we are now going to revert back to the classic graph y equals f of x. So this is the standard notation, x for input, y for output, that has been in use since the time of René Descartes back in the 1500s. So we are sticking with the classic notation here. Okay, so now first off the basic graphs. The basic graphs. So if we want to do y equals sine of x, what we are actually talking about here is, so we're talking about the graph which tracks in standard position the position of a bug vertically as it goes around the unit circle. And essentially, the important thing about it is it starts at 0 and then goes up to 1, back down to 0, back down to 1, or back down to -1, I should say. And it goes back to 0 again, and we just have some very regularly spaced points here, which we'll just draw out a few, and then also I'll go backwards in time slightly and do these ones as well. And the important thing to note is that the highest and lowest values that this graph will ever achieve will be 1 and -1 for their vertical coordinates. And then as far as the way the graph is actually going to look, it's very smooth because we are talking about the motion of a thing in circular motion. So So it will be a smooth graph, and the best way to achieve that smoothness is to draw some little guiding line segments here, and just try to pace your graph according to the little line segments. That just helps you draw like a reasonable graph. Frequently, people draw too much of a zigzaggy sawtooth path, and it should be relatively smoother. This one is a little bit too rounded for accuracy's sake, but good enough. Okay, now we know that the period of sine is 2 pi, and what that means here is that it will be back at the place where it started, ready to start all over again with its full cycle of up and down and up. So up and down and up. That's the cycle of a sine graph. And the most important thing is, so starts. At midline, and it's going up. So that's the most important thing about the sine graph. So it starts at the midline and it's going up. Now, if we're talking about y equals cosine x instead, so this is the graph of the cosine function, the important thing to note about it, so sorry, it sometimes is a little hard to draw these things freehand on paper. I'll show you how you're going to use the graphing tool that is accompanying your homework. Actually, here, it's too crooked. Too crooked. I'm going to try this again. Hopefully, the paper you're doing this on is either graph paper, which would be great, or just at least lined paper. It makes it a lot better. Now, the important thing to note about cosine is, unlike sine, the way it starts its journey is at the top. So the journey around the unit circle here. Just want to shut up for a second while I graph these. I just want to make sure my spacing is very regular here. So I just want to give myself nice regular spacing. Okay. There. Most important thing not to do wrong when you're drawing these things, freehand especially, is to have wildly inconsistent spacing in your graphs. Just for completeness sake, I'll add some little tick marks on the sine as well, just so you can see what's going on. Okay, so then we again are going to be seeing a smooth up and down motion, and once again the maximum values that it'll be reaching will be 1, the minimum values that it'll be reaching will be -1, and again, one full period will happen at 2 pi. Now, what does one full period mean? One full period means it starts at its maximum value, and it swings around, it goes down, and then back up, and then it's back at its maximum. So cosine starts at its max. Okay. So these are the basic graphs. These are the two basic graphs. The things that they have in common. They both have the same shape, and this is called a sinusoidal graph, or called a sine wave. And they both share that shape. What is different about them is how they begin their journey. And by begin here, I mean along the y-axis, so their y-intercept. In the case of the sine graph, the y-intercept occurs when the graph is at its midpoint, or at its midline, and it's on its way up. For cosine, the y-intercept happens when the graph is at its maximum value. Now we can transform the graphs of these functions, and we can, in doing so, we can modify the amplitude and the amplitude, the midline, and the period of them. So when we apply transformations such as vertical stretches, horizontal stretches, vertical shifts, or reflections, we alter some of the important properties of the graph. So let's just say this will be our default format. Y equals, we'll have a coefficient A, sine, and in here we'll have the Greek letter omega, which looks a lot like a W, x plus b. But just as easily, we could have the cosine instead. So, or y equals a cosine omega x plus b. Okay, so then, based on this format, we can untangle what the effect of each of these different transformations would be on the graph of the function. So first off, we have the issue of the amplitude, which we can think of as being the so this is the max minus the midline. So the amplitude represents, if we're talking about any kind of a trigonometric function, it represents this amount right here. So the amplitude refers to basically the stretch of the function. Ordinarily, these functions, they verge 1 unit up or 1 unit down from their midline. That's their default setting. However, if the amplitude gets if they get amplified by a factor, then that's going to change the amplitude. The word amplitude, by the way, technically in Latin means width. So we're widening the function. So the amplitude is the midline, is the distance from the midline to the max, or the midline down to the min, either way. So the amplitude is equal to the absolute value of A. So amplitude is never negative. So whatever the coefficient is in front of the trigonometric function, its absolute value, in other words, it, but without any negative signs, would be the amplitude, and that determines how widely the graph swings. So the amplitude is this. Now the period. The period, by default, would be 2 pi, and what this represents is, so the first x value for which the function's value and behavior returns to that at the y-intercept. I should say positive here, I guess. So this is how long it takes for it to complete one full cycle. So this means, in other words, one full cycle. One cycle. Alright, so we can write period, we can write it as a capital T or a capital P either way. Slightly more common to write it with a T, I think. And ordinarily this would be 2 pi. So this would ordinarily be 2 pi for an unadulterated sine or a cosine. However, if there has been a horizontal adjustment, namely if it has been sped up or slowed down, that factor will affect the period. And in particular, it is the omega here. The omega is the factor by which the x is being sped up or slowed down. And if it's being sped up by a factor of omega, then that will cut the period down. If it's being slowed down by a factor of omega, then that would lengthen the period. And what that would basically look like is some fraction below 1 here to slow it down, or a number above 1 to speed it up. Now, key points. So when it comes to graphing these functions, so these key points will be the values that are helpful for graphing that occur every quarter period. So these are the points useful for graphing, and they'll typically be the midline, max, and and minimum. Values each cycle. So the key points, the points that are helpful for graphing, are the ones that occur every quarter cycle, and they are where the graph will be at its minimum, its maximum, or its middle. So the spacing of the key points will be 1/4 of the period. So every quarter period. Now, the sequence of the key points will depend on which function we're talking about and its orientation. So the orientation of the graph is all going to depend on the root function. So the root function and then the behavior at the start. So the root function, we can have positive sign, and the behavior at the start for that will be start at midline, going up. The other possibility for sine would be a negative sign. And what this means is you just take the sine graph and you give it a horizontal reflection, and then the effect of that on the graph is going to be that it will still start at its midline, but it will start off by going down. Now, a positive cosine, that starts not at its midline, but at its maximum. And by start, we always mean the y-axis. By the way, if you zoom in on this and look at it, the shape of the graph when you are close to these peaks and the troughs will always actually resemble a parabola, so like y equals x squared. In particular, it'll actually technically be like y equals x squared over 2 in its general shape. But that's a matter for another day in another class, perhaps. But it can be helpful when you're graphing these things to help guide your drawing, to think of them as being parabolas at their peaks and at the minimums. Okay. And then the negative cosine starts with the minimum value. So all of these are, they are all periodic functions, so in a way there's no such thing as the starting point, but what I mean by starting point is the y-intercept here. Okay. Last item in the drawing of this will be the midline. So it is possible for these functions to encounter a vertical shift, and that will change the midline. So the midline. So this comes from a vertical shift. And the midline will happen when y is equal to, or will be at y equals b, the vertical shift. So this is going to be shifting up from a default value of 0 up into some other value. Alright, so let's just start easy by just taking on some functions and asking ourselves what their amplitudes, periods, and such things would be like. So to begin with, let's just take the following. So example, determine the amplitude and period, those are the two most important things for the graphing of functions. The amplitude and period, the one tells you how wide, and the other tells you how wide basically in the other orientation the graph is. So these are the two most important of the things. The other ones are a little bit more like icing on the cake. To determine the amplitude and period of the function. All right, so first off, let's just take something relatively straightforward. Y equals 3 cosine x. Now, the way we can do this is we just identify the ingredients that are playing the roles of A, omega, and B. So A equals 3. As for the omega, that's the part that goes right here. And because there is nothing written there, that means it's a coefficient of just 1. So A equals 3, omega equals 1. So that means that the amplitude will be the absolute value of 3, which is just 3. The period would be T equals 2 pi over omega, which is just 2 pi over 1, which is just 2 pi. So here there has been only a tiny change to the function, and that has been a vertical stretch by a factor of 3. And the effect that will have is that it will amplify it by a factor of 3 vertically. Okay, now how about this? Y equals negative sine 1/2 x. Okay. So now once again we just take the pieces as we can see them. So A would equal the coefficient on the sine, and that's going to be -1. As for the omega, that's going to equal the 1/2. So then for the amplitude, it's going to be the absolute value of -1, which is just equal to 1. For the period, T is equal to 2 pi over omega, which is equal to 2 pi over 1/2, which one of the ways we can write this that is most convenient here would be to rewrite it as a multiplication by the reciprocal, or you can think of it as multiply the top and bottom by 2. Either way, and that's going to be 4 pi. So the effect of the omega here is that essentially by multiplying it by 1/2, you are slowing the function down, so you are making the period longer by a factor of 2. You're making the function all go half as fast. The omega here is sometimes called the angular velocity, or it's also called the angular frequency from time. Sometimes it's a little weird, but it basically tells you if the function is being sped up or slowed down from the original orientation, which has, or from the original configuration, which has an amplitude, which has a period by default of 2 pi. Okay. Now for C, let's look at something like this. So y is equal to -3 cosine 3x. Alright, so once again, the amplitude is equal to just the coefficient in front, and the angular velocity, or the angular frequency, is equal to the number in here. So omega equals 3. So again, we just go ahead and start with the amplitude, then find the period. And the most important thing about the amplitude is that it cannot be negative. It doesn't make sense to say that from the midline the maximum is -3 above it, because it wouldn't be the maximum then. And so we can't have a negative value as the amplitude, so we just do this. Alright, so the amplitude is 3. And as for the period, that's 2 pi over omega, which I'm going to skip writing all that stuff, and I'll just write 2 pi over 3. Nice and easy. Alright, now let's deal with something where the numbers have some interesting quirks to them. So how about D? So here y equals 9/5 cosine negative 3 pi over 2 x, and that'll just be our function. Now here's a little hint for what to do on things like this. When the argument, that's the input, of the trig function is negative, use the even-odd properties to rewrite it. In a more standard form. We will typically avoid thinking about what does it mean if it has a negative angular velocity. That's just not something we wish to consider right now. And so, if we have something like this, what we would do is think about whether cosine was even or odd, and make our adjustments accordingly. And here, so I would write it without the negative in front of the 3 pi over 2 here, and I would put a negative there if, actually here, let me do this in slightly more steps. So I'd pull the negative out to the front if cosine were odd. If it's even, it will just disappear. So cosine is an even function, you'll recall. So cosine and secant are the two even trigonometric functions. The other four are all odd. So then this is the same as rewriting the whole thing without the negative in the first place. So then what's that mean for our amplitude? That means the amplitude, or sorry, the A, not necessarily the amplitude, but the absolute value of A is. So the amplitude, or sorry, the A, the stretch factor is 9/5, and then the omega, we can consider to just be 3 pi over 2. So then, when it comes to the important information that we are being asked to find here, the period and the amplitude, we start with the amplitude, and that's equal to the absolute value of 9/5, which is just equal to 9/5. Remember, the absolute value, all it does is take negatives off of negative numbers. As for the period, here we go. So it's going to be 2 pi divided by omega. So the easiest way of dealing with this would be, again, rewrite it as a multiplication by a reciprocal. And what's that going to mean? It means, oops, sorry, the 3 doesn't cancel. I mean, the pi cancels. So what's that going to equal? It's going to equal 4 on the top and 3 on the bottom. So you can think of this as being over 1 if you're not comfortable multiplying together numbers of different formats like that. And the important thing is that what we have here is a period of 4/3. We did not use a negative value of omega to get a negative value for the period. That wouldn't really make sense. The period is typically only something that we consider as a positive number. So there is a world in which you can make sense of it in a negative way, but that's not really the way we are going to think about it. Okay. Now, let's discuss some general strategies for dealing with graphs of these trigonometric functions. So, let's talk first about matching. This is something that will come up in your homework. Matching equations and graphs. So the most important thing is just figure out the period, figure out the amplitude, figure out the orientation, and from that you should be able to match a graph with a graph. So matching equations and graphs. So the key is identify the amplitude, and again that's max minus mid. Identify the amplitude, the period, the midline, and the orientation of the graph. And use it to construct the formula. Or use them. All right, and just as a way this can work, let me show you, at least on the textbook, what the corresponding homework on this would look like. You might have a bunch of graphs here and a bunch of formulas down here, and it's your job to match the one with the other. Now, on the online homework module, the way it will work is, again, you'll see the graphs and you'll see the functions, and you'll just have to drag them and match them. But the important thing in this is that we can see for each case what the amplitude will be and what the period will be. So just, strategizing how you would do this. The amplitude would here be from middle to the top. So that's 2 minus 0. So that's 2. Amplitude 2. Same. Amplitude 2. Amplitude 2. Amplitude 2. Amplitude 2. Amplitude 2. Amplitude 2. And then here we'd have amplitude 3, 3, and 3. So automatically when it comes to matching, we know that E, F, and G are going to be ones that have a 3 in front. Maybe positive, maybe negative. That'll depend on the orientation. But those will be the ones that have the 3 in front, and the rest will all have 2. And then, as far as the orientation goes, we can look at that next if we want. So we can figure out what we are talking about in each case. So here we're starting at the maximum. That means positive cosine. Here, we're starting at the midline, going up. That means positive sine. Here, we're starting at the minimum. That means negative cosine. Here, we are starting at the midline going down. That means negative sine. Here, starts at the maximum, positive cosine, positive sine, negative cosine, negative sine, positive cosine, and positive sine. Once again, the orientation is determined by how it starts. Is it at the middle, the maximum, or the minimum value? And if it's at the middle, is it going up or is it going down? And that'll tell you two things. It'll tell you whether the root function is a cosine or a sine, and then also whether it's positive or negative. And then the last thing to disambiguate the similar cases here is to look at their periods. So what is the period in each case? Well, period is how far it is until it's back how it starts. So the starting point here is the y-intercept, and so that's 2. It doesn't do that again. It's not at the maximum again until it's at 4 pi. So the period here, 4 pi. The period here will again be 4 pi. The period here will again be 4 pi. The period here will be 4 pi again, looks like, because it's at the middle going down. That happens again when it's at 4 pi. And then we've got some other ones here. So these ones are different. So these ones have a period of just 4, not 4 pi. 4, 4, pi, pi, and then the period of this one would be halfway between there and there, which those appear to be spaced by pi over 4, so that would be pi. So the periods will be, so the periods here would be 4 pi for most of the first ones, and then 4, and then pi. Now, if you have the period and you want the omega, the only thing that you have to do there is once we have the period, given period, get omega by taking the equation t equals 2 pi over omega and rewriting it. Multiply both sides by omega, dividing both sides by t. So get omega by doing this. Which becomes, so it's multiplied by omega, divided by t, 2 pi over period. So for example, let's just say that we identified a graph whose, so we have a sinusoidal graph which has a maximum, say a maximum of 5, a midline of 0, a minimum of negative 5, a period of, let's just say, 3 pi, and starting position let's say, max. So in other words, what we're talking about here is 5 is the maximum, -5 is the minimum, 3 pi is 1 full period. So then if we break it into quarter periods, those will be the key points. And that will be, and it starts at the max, it says. So that means so then it'll be down to here, up to there, and back up at its maximum by the end of one period. Okay, so then the amplitude would be the distance from the maximum down to the midline. 5 minus 0 is 5. The period was 3 pi, we were told, which implies that the omega will be 2 pi over the period, which cancels a little bit and becomes 2/3. Alright, the orientation. So if it starts at its maximum, that means we are talking about a positive cosine. And so together, the formula here would be, so the formula would be, so 5, the amplitude, and it would be a positive or a negative, depending on the orientation, and the orientation indicates that it would be positive. It's cosine, it's 2/3 x, and it would be plus 0. So this particular section doesn't have a lot of vertical shifts, only a few. So that's how you go about constructing the formula from the graph. And then the other task here is to create a graph based on the formula. And the key, or the main approach here, the approach would be use the formula to identify the important information. Then plot the key points. Each quarter period. And connect them with a smooth curve. Alright, let's just see how this would work in practice. So in practice, the way we would go about this, let's start with just a formula here. Alright, the instructions here will be graph the following. Graph the following. label the key points. Oops. Show at least 2 periods. And identify the domain and range of the function. Now, before we actually get into this, let's remind ourselves what the domain and range referred to. So recall, domain is the set of all possible x values on the graph. And range is the set of all possible y values on the graph. And we will typically use interval notation for domains and ranges of this sort. Okay, and just to see how that goes, the easiest if we just see it in practice. All right, so let's just start with one, nice and easy. How about y equals 3 sine x? A nice gentle start. Okay, so let's identify all the things that we can identify about it. So the amplitude is going to be 3. As for the midline, there's no plus b on this. So the midline is going to be at 0. And then that means that the maximum is going to be 3 above the midline, just 3. Minimum, 3 also. These are just some helpful pieces of information. The period is going to be 2 pi over omega, but that's just 2 pi over 1, just 2 pi. Alright, so then what does that leave us with? That's going to leave us with key points at, so it's going to be at every 2 pi times a quarter. In other words, pi over 2. And then the orientation, it's a positive sign, which means start at mid going up. Alright, so let's just see how this would all play out. So what we can do here is we can just start by laying out the foundations of how high and how low the graph will be going. So the maximum and the minimum values, put those on there. And then we'll put a period. Let's just say that's the first period. So the period is 2 pi. And then another period after that would be 4 pi. And then the key points then would be every quarter period, which is easiest to do just by breaking it down like so. Just break the period first in half, and then each of those in half again. Okay, now it says label the key points, and I consider having tick marks to be label enough, really. Any tick marks that make it clear what the values would be are sufficient label. Now start at midline, so that's the way sine begins, and then be at the maximum, and then be at the minimum again, and I think my midline here is not my key point here is not spaced well enough. This is the time to fix the spacing of things if you need to. Once you start drawing it, it's going to be too late, so make sure that you follow the sequence up and middle and down and up and middle and down, or sorry, up, middle, down, middle, up, down, or up. You see how it goes. Middle, max, middle, min, middle, max, middle, min, middle, max, middle, min, etc. forevermore. And then we just draw it according to what we've got here. Just follow the trail. And I like to draw at the key points little line segments to help me pace my graph, keep it from getting too zigzaggy. Okay, now looking at the graph here, it will continue obviously, and it continues this way as well, but we drew 2 full periods, so now let's ask ourselves about the domain. Well, the x values. Where do the x values begin? Where do they end? So technically they go infinitely far to the left, infinitely far to the right. So the way we write that is negative infinity to infinity. So this means all real numbers. So the x values here, they start way on the negative left side of the number line, and they end way on the right side of the number line. But the number line actually doesn't have a beginning or an end, so we represent the fictional points with infinity. And then as for the range, what is the spread of y values this is capable of reaching? Well, the lowest is -3, that's the minimum. And then the maximum is 3. And we use brackets, remember. Means included. So this is just a refresher on interval notation. Hopefully you've seen it before. But if it's a bracket, that means included. If it's a parenthesis, that means excluded. So hard versus soft equality or inequality. So that's how that sort of thing would go. Now let's up the ante a little bit with another detail. How about we make the graph something like this? So B. How about we do 2, y equals 2 cosine of 1/4 x. Two cosine of 1/4 x. Alright, so first off, the usual stuff. We'll just figure out the amplitude is the 2, so you take the coefficient in front and the absolute value of that. Which there's no shift for midline, so this is going to be 0, which means that our max and our min will be at 2 and -2 respectively. So those are just important things to know. the amplitude goes, it tells you how far up and how far down it goes from the midline. Okay, now as for the period, it's going to be 2 pi over omega, which is here 1/4. Now, how does that go? So it's going to be 2 pi times 4 over 1. If you're dividing by a fraction, you can just rewrite that as a multiplication by the reciprocal, and that'll be equal to just 8 pi. So then the key points. Those will be every 8 pi times 1/4, which is just equal to 2 pi. Oh, and the orientation. Since it is a positive cosine, that implies that what we are doing is start at max. Okay. That's enough to know to get us started, so let's then plot things out. So 2 is the highest, -2 is the lowest. And now once again, I'll just start by projecting out 2 periods, and then I'll break them each into quarters. And what is this? This is 8 pi. That makes this 16 pi. And I don't need to be overly particular in labeling all these things. That's what tick marks are for. You might just make a heavier tick mark for the middle and then smaller ones for the quarters. And you don't have to go nuts on labeling here. All right, so this is not a negative here. That's just 2. All right, so now being a cosine means that its first key point is going to be the maximum. That's the starting configuration here. And then it just cycles max, min, max, mid, min, mid, max, mid, min, etc. Hard to say, easy to draw. Now this part is quick and easy, and if you do it right, then it'll set you up for sketching the graph. So once again, use little line segments to help pace your graph. Also, I recommend if you're doing this on paper like this, do it with little dotted line. It's a lot easier to keep your graph from getting a little bit off kilter. And once we have finished a second period, we should be back at the starting point. This is a periodic function. And once again, if we think about the domain and range, where does this graph actually start? Never. We started drawing it at the y-axis, but that's not actually where it starts. This is periodic. It goes infinitely far in both directions. And so we actually can just say that it starts at -infinity and it goes to a positive infinity. So it's, in other words, all real numbers. And as for the range, again, we can just look at the minimum and maximum values, -2 to 2. The range is always going to be on these because they just smoothly swoop up and down. They don't miss any y values. There are no gaps, so it's just going to be smoothly minimum to maximum. All right, let's see. How about something that has some other stuff going on? So how about something like this? Y equals -3 cosine pi over 4x plus 2. So we've got some extra features here. We've got a negative in front, which is going to affect the orientation, and we've got a +2, which is going to affect the midline. So let's discuss these things. So the amplitude is the absolute value of -3, which is just 3. Now the midline now is actually this vertical shift, which is 2, And that means that the max will be 2 plus 3 is 5. The min will be 2 minus 3, which is -1. So -1 is the minimum value of the y's, 5 is the maximum value of the y's, the midline is at 2. And as for the other stuff here, so the period, t is equal to 2 pi over pi over 4, which again we just write as multiplication by the reciprocal, the way you divide fractions. And then if we find any canceling pairs of factors, we would let them cancel, and that gives us just 8, which then means the key points will be every every 8 times a quarter, which is 2. So the key points will be happening every 2 units. What else we need? The orientation. So it's a negative cosine, which means we start at the minimum. Okay, so let's think about how this is going to look. So when it comes to drawing this, you need to use a little bit of strategic thinking in arranging your graph so that everything will fit on there in a nice fashion. So here, I'm going to need my function to go all the way up to +5 and -1. So that means I'm going to want more space on the positive side than on the negative. Now, okay, so if this is -1, so then that'd be 1, 2, 3, 4, 5. Let's see right there. Halfway between them would be the midline, which is always a good idea to put on these ones. Whenever there is a shifted midline, you definitely want to put that on there for your graphing convenience. So this is a 5. And now, let's plot out a period and another period. So that gives us 2 full cycles. And now the key points are going to be happening every quarter of that. Okay. Now this is a negative cosine, which means it starts at its minimum value. And then by the time the next key point, it should be at its midline. And then it should be at its maximum, and then it should be at its midline again, and remember its midline is this value here. Then it should be at its minimum, then it should be at its midline again, then its maximum, and what were these values? So this was a period of 8, which means that'll be 16, and I won't bother labeling the other ones along the way. That's what the tick marks are for. And then by the end of it, it should be back down to its minimum. Okay. And once you've done that, that's the hard part, getting it all laid out. And then the easier part here is actually just connecting the dots. Make sure you get every key point in there. And there is our rough graph. Now, as for the domain and range, once again, the x values that are on this graph, it would be in fact all x values. It continues infinitely far to the left and to the right. We don't stop just because we get tired. It keeps going. All right, and as for the range, once again, it's a matter of going from the minimum to the maximum. So the y values bottom out at -1, and they max out at 5. Okay. Now let's do one more twist on all this. How about something like this? So one more example. Let's go with y equals 1 minus 2 times sine of negative 3x. All right. So first off, this is not our typical format of things, so let's just reformat this into something that we are more familiar with. So we'll reformat that. So sine, actually, so first off, we'll deal with just the fact that this is not written in the typical order. We want it to be a sine omega b. So y equals negative 2 sine negative 3x plus 1. So we just reorder it, so instead of it being a positive 1 minus this, it's a negative this plus 1. Now, sine is odd, which means then that we can actually pull the negative out to the front, and it essentially cancels. So plus 2. And now it's not negative 3x anymore. And now, from here on, it becomes much more straightforward. So sine is odd, so the negative comes out, and it cancels. So the amplitude is now 2. Well, we can see it because we've reordered it so that the amplitude is written first. The midline is the vertical shift, which is going to be 1. The maximum is going to be the midline plus the amplitude. And the minimum is going to be the midline minus the amplitude. The period. It's going to be 2 pi over 3, which is actually just fine. And then the key points then turns out would be every 2 pi over 3 times 1/4, which those would cancel a little bit, and it'd be every pi over 6. But we won't go too crazy on labeling those just because they are fractions and it'll just be awkward. Orientation here, we have at the end of the day, it ended up being a positive sign. The negative and the negative canceled out, and it became a positive sign, which means start at mid going up. All right. So then, here we go. So let's think about it again, strategize. Our maximum here is 3, our minimum is negative 1. So we're going to need more space above than below. All right, let's call that negative 1. And then that means positive 1, positive 2, positive 3. A little bit there. All right. Now, the midline would be at positive 2. Sorry, the midline would be at positive 1, which would be right here, halfway in between these. And let's call, got a little bit crooked here. I'm just gonna fix it. And let's call that one period. And then that'll be the second period. Maybe it's a little bit. Okay, there we go. There we go. There we go. All right. Getting a little tired here, and my graph is suffering, but we'll figure it out. So it's 2 pi over 3, 4 pi over 3. Okay. So those would be the first two periods here, and then when it comes to drawing it, if this is a positive sign, then it's going to be starting at its midline and it's going to be going up, and then everything else will be bouncing back and forth based on the midline, maximum, the minimum, at each of the key points. Which one was my official one now? The lower one, right? So this one got a little sloppy. Oh well. Try to do it on just a blank piece of printer paper using just a pen. These things will happen. Alright. It's not coming out that bad. Also a tip, they are easier to draw the smaller you make them. The bigger you make them, the harder it is to get the swoops right. Alright, domain. Well, it may not surprise you to learn that the domain of this function is negative infinity to infinity. Where does it start? Never. Where does it stop? Never. We started drawing it at the y-axis, but by no means is that the beginning of the story. The function goes infinitely far in both directions, and that's what the domain represents. Now, as for the range, that's a question of how far it goes in the y direction. Well, it goes from a minimum y value of -1 to a maximum y value of +3. Those are the limits of the range of the function, the maximum and minimum y values. Okay, so that's how we draw these things by hand. Now, given a graph, we can find a formula by reconstructing the pieces A, sine versus cosine, omega, and B from the available information as to the amplitude, orientation, period, and midline. So just as a quick example of something like this, let's say that what we had was a graph that's like this. So find a formula. And let's say that we have -1/2, and then other important information, -3/2. be -1 then. We have a graph that is going to be so I'll just draw quickly one period of it. And let's just say that what we see here is that it is like this. So it goes so we have a graph presented to us, and this is the important stuff about it. Namely, from this, and then let's say that this is equal to right here. Let's say this, that what we're given is that this is 2 pi over 3, and this is 4 pi over 3, and then the other tick marks are not labeled. Now let's just figure out what we can figure out. Okay, so first off, we can see that the maximum value here is -1/2. We can see that the midline is equal to -1. So that means that the amplitude is going to be the max minus the midline is equal to -1/2 minus -1, which equals +1/2. And that makes sense. The amplitude is the width from here to here. So 1/2. Okay. Orientation. So starts at mid, going down. And starts means at the y-axis, and so there, in other words, where x equals 0. So that's the starting place, and that implies that we are talking about, well, middle means sign, going down means negative, so negative sign. All right, and then other stuff, the period. The period, t is equal to 4 pi over 3. Notice the period happens when it is back to how it started. So when it started, it was at the y-axis, it was going down from its midline, and so the period would be whenever it gets back to that. So the period is this, which then means that omega is equal to 2 pi divided by that, which is 2 pi divided by 4 pi over 3, which we can rewrite as a multiplication by the reciprocal, so it's 3 over 4 pi. And the pi's will cancel, and furthermore, a lot of this will cancel, and we'll just get 3/2. So then, the formula that we can make here will be y equals, let's see, our amplitude, so this means that A is going to equal -1/2. So it was 1/2, but then the orientation indicated that we're going to be talking about a negative value of A. So it's -1/2. We're talking about a sign here. The 3/2 is the omega, that's what goes as the coefficient of the x, and then the midline is -1, so it means -1. So that's how you get the formula off of a graph. Now this is all us doing it on paper. However, part of your homework is, of course, to do these things on the Pearson module. And so let me show you how that's going to have to work. Alright everyone, what you see before you now is the style of question that will appear on your homework for this particular section. And what they're going to want you to do is graph this function. We know how to do it on paper, but how do we do it using their tools? So here's what we have to do. So first off, let's start by finding all of the important things that we need to know here. So based on this part, we know that the amplitude is going to be 4. Alright, now as for the period, we know that that's going to equal 2 pi over 2, which we rewrite in our usual fashion as 2 pi times 2 over pi. So rewrite it as multiplication by the reciprocal, cancel things, and we get 4. Okay, so these are two important things that we need to know. We also have here a midline that is involved of 2, and we know that it is a sine, and it's a positive sine. So it's a positive sign. So those are all of the important pieces of information that we'll need to know to draw this. If we were drawing it by hand, we would just put all the pieces in play here. We'd have the midline, we'd figure out what the max was, we'd figure out what the min was, all those things. What we do here in this one is we actually so you click the thing here that says click to enlarge graph. And now we have different tools to choose from as far as what we are going to be producing here. So this one represents the sine function. So you can see that it's got a midpoint that is at the midline, whereas this one has a midpoint that is at the minimum. And that means it represents the cosine function. So we have a sine tool and a cosine tool, and we choose the one that fits us. So a sine tool, and then you just actually just click somewhere. It doesn't matter where you click. It automatically orients the sine with an amplitude of 1 and a period of 2 pi. So kind of default sine. Now here's where you put in all the pieces that you would need to customize for your particular function. So your amplitude, you'd put that in here, and now, if you wanted it to be a negative 4 sine, you might think, okay, put the negative 4 in there, but nope, amplitude can't be a negative number; it has to be positive. So the way you accomplish that is with this little box down here, reflection about the x-axis. So it's a vertical flip. So it turns it upside down, right side up, upside down, right side up. The case that we're dealing with here has a positive sign, so it's right side up that we want. If it had been negative 4, we'd go like that. Now, all right, that's all well and good. And then the period. So the period here is by default 2 pi, but that's not what we want in this case. We want a period of 4. Okay, so there's that. So it's a period of 4. Quick reality check here. Does it return to its original configuration at x equals 4? Sure enough, it does. Now, that accounts for everything except for the midline. And the way you get the midline in play here is by doing the vertical shift. So the vertical shift here, oops, I wasn't done with that. So vertical shift, you just click on it and it'll bring this thing back up. I was trying to draw on it, but it made it disappear, so I can't do that. So to do the vertical shift here, you just take this and you can just pull it over however far you want it to be. So it's unfortunate that you can't really enter the number, but the vertical shift that we want in this case is 1, so the midline should be shifted up to a positive value of 1, and that's what we appear to see here. So call that good and check our answer. So as soon as we hit enter on that, it just inserts the graph in here, and we can check. Oh, whoa. Oh, oops. Carelessness on my part. What is our midline supposed to actually be? It's not supposed to be 1, or it's supposed to be at 2. So that was just me losing track of the details of the problem. I needed the vertical shift here to actually be 2. So my bad. Sorry about that. So save that. Whoops. That's why you get multiple tries. Okay. So that was just a little bit of carelessness on my part. Okay, so now we continue, and it asks us the next pieces of information. So it wants the domain and it wants the range. Now it says type your answers in interval notation. Now the domain of this function is negative infinity to infinity. So how do we type that? Well, we start with the parentheses in the usual fashion of domain and interval notation. And now down here, we've got these extra bits that we can use to put in. So infinity, you can do that with that button right down there. Oops, but I want this to be a negative infinity. So negative, and then infinity, comma, infinity. And this will be the domain of all of the sinusoidal functions, all the sine and cosine. May be different when we get into the more exotic functions, like all the reciprocal functions and tangent, but for sine and cosine, they go infinitely far to the left and right. You can zoom in, you can zoom out, but the function just keeps on going. And now for the range, what we want is, again, interval notation. And because it actually includes the values of negative 2 and positive 6, the maximum and minimum values, you can see them on the graph there. We go negative 2 with a square bracket, not a parenthesis, but a square bracket, and then up to 6. So then we check our answer, and that's how we do those. So if we have a sine, that's how we do that. And if we have instead a cosine, we do something very similar, but we would just use the cosine function. So let's just have a quick look at this one. So first off, we need to reformat this. So it's negative 2 cosine 3x plus 6 would be the usual way we'd write it according to our default format. Okay. So then the amplitude here would be negative 2, not negative 2, the absolute value of negative 2, which is just 2. The period would be 2 pi over 3. The omega here is 3. And that's good enough. We don't need that. Not an easy eraser on this thing. Okay, and then midline was 6, and the orientation was negative cosine, which implies start at minimum. All right, so I think those are all the pieces of information that we're going to want here. So using all that, let's give it a try. So this time it is not the sine tool that we want, it's the cosine tool, because it's the cosine function that we're talking about here. And you just click anywhere on the graph and it'll start you with a default cosine with an amplitude of 1, a period of 2 pi. So we need to change some things about it. We need the amplitude to be 2. We could have tried negative 2, but it wasn't going to work because amplitude has to be a positive number. Okay, so that's fine. Now how do we make it negative? We reflect it about the x-axis. So that gives it a vertical reflection, and that's how we end up with that. And then we just have to adjust the period. So 2 pi, you can just do divided by 3. Okay. Save that. Oh, wait. I did not put in my vertical shift yet. The Achilles heel on this is getting those vertical shifts in. All right, so is that 6? The vertical shift is the most awkward part of this whole little tool, but it looks like I've got that in there now. And so now check my answer. All right, good job. Now domain and range, quickly here, same as before. We do negative and then infinity using that little option down there. And then infinity again. And we check our answer here. And then finally, if I want the range, I just have to look at where the minimum is. That's at 4. So that's going to be bracket because it's included. So it's going to be 4, comma, the maximum, which is 8. And then square bracket again to end it. And we check our answer. And that's that. So the way you produce these graphs is by using their little built-in cosine tool or sine tool, as the case may be, and you can tell what they each are by their orientation. All right. Well, let's call that a day. So this is Math 254. Oh, and I just let you know, there are a couple of application problems, or is just really mainly one application problem in which you are given some information about a current of an alternating current circuit, and you can find the information about the period and the amplitude just according to the usual format that we know and love. And so although it's technically worded in words, it doesn't actually require you to do anything outside of what we did before. Okay, so that's 5.4 for you, and that's how you do the online homework. So I will see you next time for the next episode of Math 112. Until then, bye.